Okay, at this point in the course you are familiar with classes, and in the previous lesson we talked about pointers and references, and in that lesson where I talked about the memory segments, I compared the stack and the heap memory segments. I provided an overview of how function calls work. Right, when a function is invoked you push a stack frame onto the stack, and when you return from that function to the calling function, that stack frame is popped again from the stack. Now what it boils down to is there is some overhead associated with function calls. So the creation of the stack frame, the copying of the arguments or addresses depending on whether you copy by value or by reference. You also have to copy the return address so that when the stack frame gets popped off of the stack so that you can return to the calling function. In other words, you need to know the return address. So at some point you have to store that return address and you have to retrieve that address as well. The point is there is some overhead associated with function calls. Now we can declare a function to be inline, and that will reduce the overhead associated with function calls. And in some cases it can significantly increase performance, especially if the function is called in a loop. An inline declaration is a request to the compiler to replace each invocation of the particular function with the fully expanded code. Now the compiler may actually refuse to inline a function if it is too complex. So if the function contains loops and switch statements or simply too many lines of code, then again the compiler may refuse to inline that function. Now if the compiler refuses to inline a function, it will basically generate regular function calls. So that function will be used as if it is a regular function, right? It's not going to be replacing each invocation of that function call with the expanded code. Here's an example of inline function expansion. Now this is not necessarily what will happen behind the scenes. This is just to give you a basic idea. So on the left I have a function, greatest int, that is declared as inline. You can see the keyword inline to the left. Then we have int and then the function name. The function has two formal parameters x and y, both are integers, and then in the body of the function I simply return the greatest one of those. So if x is greater than y, then return x, otherwise return y. In main I have some demo integer and I set that equal to whatever that function returns. I pass in two integer literals 5 and 10, and then I simply print out demo integer to test that out. On the right is what that will basically expand to. So in main I have the demo integer declaration again, but that inline function is now expanded, and basically what that means is the formal parameters will now be inline, so it's going to be right here in main. So we declare x and y, we set x to 5 and y to 10. Then we do the same thing that we did in the body previously. We set demo int equal to whatever that expression evaluates to. So is x greater than y? If yes, return x, otherwise return y. In this case it will return y, and we assign that to demo int. And then we simply print that out again. So just a high level example of what this inline function expansion will sort of evaluate to. And of course in the example to the right we do not have a function call, so that means we don't push a stack frame onto the stack along with the return address and everything else, and we don't have to pop that off again and return back to that return address later on to continue with the program execution. So from this example and from our examples on the stack in some of the previous lessons, you can start to see why this will be more efficient. Right, we are now avoiding that overhead of a function call. Here's an example for reference in Visual Studio. I have the inline function, greatest int, it returns an integer and it's going to return this. And of course in main I just have this, so I do the list initialization because it's simply going to set demo int to 0 as I mentioned in previous lessons. Demo int, I set that to whatever that returns, and then I print demo int out. You can run this, you'll see it'll work fine. Prints out 10. Change that maybe to 15. First argument 15, second argument 10. And of course we should get 15, and that's what we get. Some disadvantages of inline functions. The inlining of a function can lead to a lot of duplicated code, which can make the compiled code larger, and because of that the program will occupy more memory when it is running. That being said, the potential performance gain for small functions can be significant, enough to warrant the additional memory usage. We also have inline member functions. Member functions that are defined in the body of a class are implicitly inline, so you don't have to inline those member functions, they are implicitly inline. It's best to use inlining on small member functions such as getters. Then you don't want to inline a function that does a lot of complex stuff. Functions with only a few lines of code are more sensitive to function call overhead, but if you have a function with many lines of code that does a lot of stuff, proportionately those functions benefit less from inlining. And as I mentioned, in some cases the compiler may not even inline that function for you. Here's a quick example again using the entity class. In the public section, I have this member function, int getMember. Now because this function is defined in the class, so we don't just have a declaration, we also have a definition. You can see the body right here. Now because of that, this function is implicitly inline. So I don't have to inline it, it is already inlined. Now that being said, if you have the definition outside, as I have right here, so I have the declaration in the body of the class, and I have the definition outside, then you need to specify if you want that function to be inline or not. You can do that in the class right here, so in the body of the class, but this is not typically how you would do it. But it's best practice to specify the function as inline in the function definition, like this. I'll just build and run this and this will work fine. Right, all I do in main is I have an instance of entity and I do entity1.getMember, just as a quick example.